use that. So basically that for free. Now I just need an espresso machine. I love espressos. Wednesday. Looks like you just like beat up someone the way you walked in.
Myself. That's why I just put it.
1.
Not me.
Hi.
Yeah, so it shows all of you. This time we will get to the level when we will operate several cameras and focusing on those who is speaking. If you want to, if he or she wants to be picked by the focus. Well, thanks for coming again. I am fearing that I will come to the empty class and it never happens, so I'm keeping me very happy. Thanks for coming. So, who we are and what are we doing? This is physical chemistry class. We want to describe reactions and characterization of chemical materials as an outstanding goal for our future. And with this deep motivation, we are realizing that there are no molecules without electrons, and electrons are most challenging part of molecules. They are light and vivid, like to move quicker, and therefore we focus on the principles and mathematical tools to describe how electrons behave in molecules, with possible future, not possible, definite future of predicting outcomes of experiments, or setting up, paving a way to predict outcomes of experiments. Right? It is where we are. Then we decided to go on a picnic in a figural saying. So we do have principles and some of mathematical tools, but we need to pick a simplest possible problem to analyze and to see that our tools work well or trustable, reasonably well. And we decided to look at the imaginary, fictional universe that has only one electron. Then you did. Can you please check that? Oh, everything's fine. I just on some of the equipment it was showing unit mic, but it is not. So through discussion last time, we collectively, constructively, cooperatively, we creatively selected the right scientific task that we can potentially solve with our mathematical tools. So we set up two hypothetical statements that probably would govern motion, evolution, behavior, properties of electron in the empty universe. One was rephrasing of Newton's first law, that if not perturbed, will keep the average velocity, right? And second one, we have hypothesized that if you squeeze electron in a localized form, but due to the way the nature, it may decide that it wants to expand, or maybe contract, but definitely change the area of space where it protrudes to. And we set up this question in a more formal way as a find a width of the central Gaussian distribution of electron space and see how does it change with time. And hypothesis is that if you expand, take more space. But now, that's it. The rest, about 2-3 lectures, where you, if you hate math, you can just fall asleep. Then after 3 hours, I said, yes, we have a wonderful, surprising result that it expands. So I'm just paving the way. But we are going through the a little bit boring and hard effort to support this hypothesis. I'm not expecting too much of enthusiasm because it is hard, but we will develop some mathematical muscles and later on the skills that we gain in attacking these simple problems will be helpful in something more complicated. And it will shorten our time that we invest into later investigation of more complicated problems. What else? Well, we were recalling all the tools that we can plug in, like 3 ways to predict future, expansion coefficients. For any, if we accept the 3rd way to predict future, we need to formulate the Hamiltonian, find eigenfunctions and eigen energies of stationary states for this Hamiltonian. And it looks like we already did it last time, right? Good. So what are the eigenfunctions called? Oh, what is the Hamiltonian of electron in free space? Do not give me like 5-star equations, just tell something simple.
Is that e to the negative I h?
You started to give 5-star equations. So it's kinetic energy, where momentum operator is replaced in terms of derivative over space, right? Something like this. What are the eigenstates of the Hamiltonian? We were not literally finding them, but we plugged in one of the test function and voila, it did work. So what was this test function?
A wave.
It was a wave, yes, correct. It was a which wave? Circular, cylindrical, elliptic, linear.
Plane.
Yes, perfect. Plane wave. So we have the one of the kinetic energy contributing to the Hamiltonian. We have plane wave as eigenstate, and we do have eigenenergies. How do they look like? If you have plane wave that has index k, which is same as momentum, like k times h will be momentum. So in terms of momentum, not operator, but eigenvalue of momentum, what is the energy of plane wave? It is not a provocative question. You do not need to study physical chemistry and quantum theory to answer this question. Same as classical mechanics kinetic energy of a particle in a free space.
mv squared over 2.
Yes, p square over 2. And if we convert p into this k variable, it will be p sub k. Instead of p, we write h bar k, both of them squared. Right? So we have 2 out of 3 components to try the third way to try a third way to predict future in iron, in real life. And we are missing one component, the expansion coefficients. So we, again, creatively designed, because we are masters of our class, we do whatever we like. You can tell me, use different functions, I would follow you on that. We decided that if we prepare an electron localized in a specific area of space, it would be not a big thing to assume that it has a Gaussian distribution at times 0 as the initial condition, right? But now, in order to propagate it in time, we need first to convert this initial condition as function of position into form of expansion coefficients. So we from say this is a bad space. From psi of x0, which we assume to be minus x naught. What? Square. We need to go to expansion coefficients, T sub k. And I'm not going to do it, because it is your homework. So in whatever, how many long days? All weekend, Monday, Tuesday, so on Wednesday, you bring and show that the expansion coefficients will look like square root sigma 0, which is the same as here, constant pi, e to the minus sigma 0 k squared over 4, something like this. I cannot brag of strongest mind on the globe, and I can mix something constant. So we take it as an input. It is what we start with. What else is on our radar? What are we doing? What are we planning to do? So we will plug all components. As majority of you are chemists, you typically do reactions. Just measure amounts of reactants, put them in a container, mix, heat, and then get products. Here the experiment is more, well, we keep chemistry in mind, but it looks like mathematical experiment. We have a component, formula 1, formula 2, formula 3, mix together, stir, maybe integrate, and then get the answer. Same ideology, right? Components, product. Did any of you looked on the homework, how it is formulated? Do you find it challenging, or it is like 5 minutes? Not 5 minutes. Well, I have an idea that we arrange today's meeting as a twofold purpose. On one hand, it will help general class material. On another hand, I will use and show tricks, that shortcuts that help to solve exactly the same type of problem as you do in homework. So if you follow manipulations that we will do on the board, you just repeat them at home, and well, if you're confident, if you know what you're doing, it can be done within like 40 minutes. But if there are attempts and failures, it can expand up to a couple of hours. But do not expect it to be done in 5 minutes. If you spend 5 minutes and haven't got the answer, do not panic. It's normal. I think it is enough. And on Wednesdays we will. So what are we doing on Wednesday nights? We are preparing tools, instruments, and skills that will help us to avoid boring and challenging math. So we will go through some software that will allow to get to answers of some problems without deriving equations, basically. Okay, almost 15 minutes left, and I am yet on the very beginning. So it is where we did set up the width. Let me expand. Okay, a little note. What is the expected answer from your homework? How do we interpret it? So I'm sure you'll do it. It will be a successful completion. But from scientific point of view, what do these coefficients mean? Are they just boring mathematical components, byproducts, or they have any value in that? So again, mathematically, it is expansion coefficient of our initial state over plane waves. Plane waves meaning waves that have different momentum, different velocity. So if we have non-zero value of ck for given value of momentum, it means we have a substantial fraction of momentum of plane wave with given momentum in this superposition, in this initial condition. It means we compose our localized wave packet as several waves, each of which moves with its own velocity, its own momentum. And this c sub k is fraction of a wave with wave number k, or with momentum h bar times k. Try to reformulate it in your own words and make some comment. You probably can do it better than I. So, in some sense, if you have these expansion coefficients, then you do not need the wave function. They are mutually replaceable. It's like different implementations, different glance, different ways to store this information. And since this k is the same as momentum, we can call this expansion coefficients as wave function in the momentum space. Like typically we live and our intuitive thinking goes in coordinate space, where like space means point 1, point 2, point 3 that we can touch, coordinates. And here we have a range of different velocity, different momentum. And there are no mathematical laws that forbid us to think abstractly in this space of different values of momentum. Okay? So conversion between true space, coordinate space, and momentum space is by integration by this plane wave is nothing but what? It's question number 0, or first line of question number 1 in the homework. So if you have this integral times exponential and some function.
Fourier transform.
Yes, it is either Fourier transform, and some people make and call it Laplace transform. Fourier transform. So the shortcut, if you do not want to do homework, but you want to get the answer, you just look online for Fourier transform of Gaussian function and play with coefficients. So we, fortunately or unfortunately, we are not the first in the history of human civilization who take Fourier transform of Gaussian function. It's pretty popular. It has been taken many times, and it has dissolved into internet and to some tables of integrals. So it is not very big novelty for human civilization. It could be novelty and good exercise for us, but any ways where you get solution and answer and the way how to get solution is legitimate. So if you're skilled in browsing through internet and finding the right answers, it's your power to use it. Okay. Good. A function in momentum space. And now we do have our prescription, our protocol, how to predict future. So we take this expansion coefficient, we take the energies, eigenenergies, we take the eigenfunctions and add them together. So due to phase accumulation that is different, I probably want to expand it so that you see it. I don't know if any of you need and use the recordings, but just in case you can follow videos. Especially when it gets to the homework. Right. So there is a phase accumulation which is different for each term in the sum, and due to this phase accumulation, we are propagating from time 0 to time bigger than 0. So that's enough for us to know scientifically, but unfortunately we need to perform this summation. Well, here we can put square root pi square root sigma 0 e minus k square sigma 0. So we populate the boxes, take summation. Yes. Now, everything we are doing here can be squeezed in 3 minutes, but then probably we will not concentrate on important points. So I'm trying to elongate it and chew on each specific point so that we feel more comfortable and there are no surprises, that we see the logical continuation, logical line of narration. So we need to perform summation. How many terms are present in this summation? Yes. And what is the spacing between different values of momentum? Infinitely small. So if we take...
Hey, you have one. That's okay.
When I was on the 3rd year undergraduate, I was attending maybe 50% classes. And I'm so surprised that you are much better than us. Summation of infinite number of terms with grid points are spaced infinitely close. What does it look like?
Integral.
Yes. Well, it is probably true. So we take the expression from previous slide, our prescription for predicting future, and just replace summation by integral and add the infinitesimal increment of this momentum. Good? Now, surprise please. Do not be scared. You are welcome to use your notes. It is mostly for me to assess my instruction, like if I communicate well and you get an idea what we are doing. Write your name and fill boxes. Let me know who is done by lifting hand or comment. So the idea is to put not symbolic but exact expressions for energy, function, and expansion coefficient. Please attract my attention if you consider things that thing is done. I'm just curious who will be the first. Okay? Okay, first thing is brought in and awarded with a license to MATLAB software. Who is the second? Second. No? It's almost time to collect. Who's brave to declare completion? Okay. Yeah, thank you. Second from the first is also awarded with MATLAB license. And there is one more award with the third. Okay, Mark? Congratulations with being quick thinker and quick writer. Okay, now it is time to collect the rest of works. Okay, so how would I do it myself? Well, eigenfunction is e to the power I kx, right? More than half of you place in this way. Some of you put general expression.